Can you guys feel me fine? Yep. So welcome to the talk about Micronaut and Microstream. My name is Sergio del Amo. I am a core committer of the Micronaut Framework. I have been around since the creation of the framework. I've contributed to Micronaut security, the Micronaut problem JSON, Micronaut views, etc., etc., etc. So if you have any questions about Micronaut, feel free to ask. I am going to be here until Thursday, so no problem at all. Micronaut has a foundation. Microstream is one of the partners. Object computing is our main sponsor of the framework. So the framework is the foundation, sponsors the development and also that boxes the framework. Without the partners, it will not be possible. So very thanks to every one of them. How many of you have used Micronaut? Okay, no problem. So what's Micronaut? Micronaut is a JVM framework. Is open source, Apache 2 license, no strings attached. You can write Micronaut applications with Java, Kotlin, or Groovy. You can use either reactive programming or not. If you want to use reactive programming, you can use Project React or RxJava 2 or RxJava 3. You can build applications with Gradle or Maven. You can deploy Micronaut applications to AWS, GCP, Azure, or Oracle Cloud. You can use different persistent solutions. You can use Micronaut Data JDBC, Micronaut Data API, the one that we are going to be seeing today, Microstream. You can build applications that are monoliths. You can build applications that are microservices. You can build CLI applications. You can build messaging applications, for examples, Kafka, listeners, or producers, or RabbitMQ. We have many integrations. We have been around for 4 years, used by many companies in productions. The philosophy of Micronaut is to generate at build time as much information as possible. We like to say we like smart compilers and not so smart runtimes. That typically means that Micronaut applications are really fast to start and they consume less memory. Starting really fast means not just faster production, but it means faster development. So you are going to see a lot of developer productivity because you are going to see yourself writing many more functional tests because the tests are fast. So that's Micronaut in a nutshell. Today I'm going to show the integration with Microstream, which is a Java persistent layer. And I think you are going to see that in combination with Micronaut, the developer productivity is really high. We have a module about the integration with Microstream, and we have a couple of tutorials as well. We are about to release Micronaut 4. We are actually already releasing milestones, and it should be out probably the first week of July. So I'm going to show you today Micronaut 4 applications. In terms of which version of Microstream do we ship version 7 in Micronaut 3 and version 8 in Micronaut 4. And once Eclipse Store is released, that will be supported in Micronaut 4. So if you want to use Eclipse Store, that will be Micronaut 4 going forward. And actually, I recommend you to upgrade your applications to Micronaut 4. Lately, I have been adding these kind of slides to my presentations so that if you get bored, you know that it will be over soon. So there are 8 points. I'm going to find you how to find information about Micronaut and Microstream. I'm going to show you dependencies, create a root instance, test, how to use the integration with Micrometer, with the health endpoint, how to use Microstream as a cache layer, and how to use the REST and GUI application. I'm going to do mostly coding, but for the docs and links, let me show it to you. So Micronaut home is micronaut.io, and if you go to learn user documentation and you scroll, you will see all the integrations, and one of them is Microstream. So if the only thing that you remember after this presentation is how to find the documentation, that's a good start. Another thing that we are, or at least I am really proud of, is our Micronaut guides, which are step-by-step tutorials with a sample application that we generate with real code and we test in our CI server. So if you ever want to learn something about Micronaut, guides.micronaut.io is a good starting point. So if you search for Microstream, you will see like a sample application. So that's a good starting point as well. So with the first check box out of the way, let me show you an application. I have Micronaut applications. Since many of you didn't raise your hand, I'm gonna explain you. Is the code high enough, right? Yeah, I think it's fine. So how do you define routes in a Micronaut application? Similar to in a Spring Boot application or in any kind of application. Our controller annotation is named controller. And to create like a get route, you annotate with @get. To create a post route, you annotate with post. And the body of the request. So Micronaut assumes by default that you are talking JSON. You can generate HTML or any other media types, but by default we assume that you are talking JSON. So if you are talking JSON, you don't have to specify the content type or whatever you consume or you produce. This is a pretty simple CRUD interface. So I have like a get to get the list of fruits, a post to create a fruit, update to update a fruit, and get to retrieve a fruit given its name. So the name here will be kind of the unique identifier. This is an example. And the delete to basically delete a fruit, and we are leveraging here the status annotation, which basically means that we will respond at 204, which is a no content. I am using dependency injection here. So Micronaut supports dependency injection in three forms. We support like constructor injection, which is the one that we typically recommend. We support field injection and method injection. Constructor injection means you specify here, I am specifying actually an interface, and Micronaut will look the implementation for this. The interface is pretty similar. I am using the non-null annotations to allow this application to be more compatible with Kotlin, but this is you don't need to use those. I am using also validation annotations from Jakarta, so the standard beam validation specification. Micronaut supports a subset of beam validation specifications, so if you need to validate your applications, and I like validation, you can absolutely use those. So if I run the application will fail. So it's not that the demo codes are not with me, but this is a failure by design. And it's actually I have something running, so let me kill it. Let's try again. So the app is running. I don't have anything in the apex, so that's a normal page for not found. But if I try to do like a curl request against localhost 8080 fruits, we should see like a 500 error in the server, and you see here the internal error. By default, errors in Micronaut are represented by BND error. You can use problem.json, which is actually my preferred way. But in this application, I am using the default, which is BND error. So what's the error? The error, it tells me errors in Micronaut are really nice. So if you are used to more frameworks where the error traces are really ugly, that's not the case. So it's telling me that there is no bin of type fruit repository because I don't have an implementation of fruit repository, and that's what we are going to try to do. We are going to create an implementation of the persistence using Microstream. So I'm going to go here, I'm going to create a fruit repository, Microstream, for example. I'm going to implement the repository. How do you create a singleton in Micronaut? Well, you use the @singleton annotation from Jakarta, jakarta.inject.singleton. And we are going to have to implement all these methods. if you attended the Microstream talk yesterday, in Microstream you have to create like a root object, and then your graph will hang from that root object. So we are going to create a root object for that. I'm going to go and say fruit. We could call it whatever. I'm going to say fruit container. And here you could feel free your imagination. I'm going to create the simplest representation by object graph that I could come up with. So I could create like a map and have like the unique identifier of the fruit as the key and the value of the fruit. But for this example, I'm just going to create here like a list of fruits. And I'm going to actually initialize it. And I'm going to create a getter. So I have my root object, and I have an implementation which we are going to basically fill. And in order to fill it, one thing that I'm going to do is I'm going to add the Microstream dependencies. And the Microstream dependencies, they will pull transitively the Microstream SDK. So you don't need to add the Microstream dependencies as well. So I have here a shortcut. Sorry. There you go. So how you can remember those dependencies, they are documented in the documentation. So if you go to the Microstream docs, you will find those. But I'm going to show you another way, which is you go to Micronaut. Micronaut is our project generator. And the same functionality I show you here is also available in the CLI. So if you go here and you search for Microstream and you select Microstream feature, then we have here a preview feature which will show you what you are adding. So you have the dependencies here as well. So if you don't remember which dependencies to add, remember Sergio told me that if I go to launch.micronaut.io and I search for Microstream feature, the application will be generated with the necessary dependencies. So in Micronaut, Microstream supports, you could have multiple graphs in the same application. So you could have multiple Microstream instances. We support that. Often you will have only one, but we support multiple, and I will show you how we support that. So Micronaut supports different ways of configuring an application. We support YAML files, property files, TOML files, config4k, or application.groovy. I'm going to use application YAML. And I'm going to come here, I'm going to do, we have nice integration with IntelliJ. You see the auto-completion. So I'm going to select, you see Micronaut storage. When you see configuration in Micronaut of an asterisk, it means that you could have multiple bins of a particular type. And whatever you select here is going to be like the name qualifier. I will explain more about this. So I'm going to enter here main as the name. And this is the root class. So this is the fully qualified path to my root class. And I said fruit container. So I'm going to actually copy paste here so I don't make a mistake. And I'm going to select here. I'm going to clean my build folder so that you see the build folder. No build folder now. And I'm going to save to disk. Some Microstream supports several, so you can save to disk, but you can also use storage targets. I have a talk tomorrow where I will show how to deploy to AWS, and I will show the storage target that we support in Micronaut 4. And Microstream will support S3, DynamoDB, or SQL. But for today's demo, I'm going to be writing to disk, and I am going to select the storage directory, and I'm going to show here like data, something like that. So this is going to be, if you are new to Gradle, when you build a Gradle application, it will create a build folder, and inside the build folder, I'm going to save to a data folder. Nothing too complicated. So now we are ready to implement our repository. So I'm going to come here, and I'm going to inject in the constructor injection, I'm going to inject a root provider. You see it's telling me to autocomplete. and I'm gonna do constructor injection. So let me show you the API. So in Micronaut, you could go low level if you prefer to work low level with the Microstream API. You can inject the Microstream storage manager, but we created several annotations to make easy to work with Microstream, and we created also this API that we call root provider. As you see, the interface is as simple as it gets. It has a single method called root, which will give you the root object. So that's where the root of your graph starts. So that's what we injected. So for queries, it's going to be extremely simple. We are going to just use the Stream API. So I'm going to do here root provider, root fruits, and that's it. That's the implementation of my list. Let me implement all the find. So for the find, I'm going to create actually let me create an optional fruit. I'm going to do find by name. And I am creating a method because I will be reusing in the other methods. And here I'm using kind of name as unique identifier of fruits. So I'm going to go here, I'm going to use again the Stream API, I'm going to filter the fruits, and I'm going to say f get name equals name. Find the first one, right? Nothing Micronaut or Microstream, this is pure using the Stream API in Java. So I'm going to go here, I'm going to do find by name, and I'm going to, you see this could be nullable, so I'm going to go, if you don't find anything, just return null. So far so good. So now the more interesting is how you save. So let's start with create. And before saving, I have the most important slide, which is, this is the golden rule of Microstream. The thing that you modify is the thing that you have to save, right? So let's try to think this together. This is the only basically thing that you have to think in your brain, and with this in place, we should be fine. So I'm going to create another method, and I'm going to show you the annotation that we have in place to really make easy to work with Microstream. I created as protected because I'm going to use Micronaut and a round advice, so I'm going to use an annotation, and if you use private, we'll need to use reflection to essentially access that. So whenever you are using AOP, we tell you to use protect your public or package private. So I'm going to go here, I'm going to do, I'm going to call this add fruit, and I'm going to have here like a list of fruit. Fruits, and I'm going to add here fruit command. And we have an annotation called store params, and that's the sort of store parameters, and you can pass the params that you want to store, and in this case, I want to store the thing that I will be modifying, which is the fruits collection. So I'm going to do fruits, add new fruit, and fruit is name description, so I can do fruit command, get name, fruit command, get description. And what I'm going to do is I'm going to call this method from the other one. Let me do something else. Instead of store params, for this one, I'm going to do, no, that's fine, store params is fine. I'm going to return the fruit because the other method tells me that it wants a fruit. Some fruit. So we are going to call add fruit. We're going to get the list of fruits from the root object of my graph. And the other one is the parameter. And that should be the implementation. So my code will execute this method synchronized. So typically a Micronaut application will be a multi-threaded application. So that's okay. We will execute this method synchronized. So the important thing is, what are we modifying? We are modifying the fruits collection because we are adding something to it. So that's the thing that we have to save, and that's the thing that we do with the store params. Okay. What about the update? So we have fruit command. Now the method that I created, this find by name, is going to become useful. So I'm going to do fruit get name, and I'm going to do if present. So this is going to have the thing that we want to modify, which is our fruit. I'm going to say update, and I'm going to create another method in a second, which I'm going to call, again, it's going to be protected. It's going to take 2 parameters. It's going to take, actually, let me take fruit as return type. And we are going to do update. It's going to take fruit. I'm going to do here fruit command. I'm going to do f set description. So as you can imagine, this could be more complex. This is just written in the description. And here we have another annotation. So we have another annotation that you could use. I could use the same store params. We have also store return. All of these annotations supports a storing strategy, which is lazy by default, but you can change it to eager. And we have also a store root annotation that you typically will not use, but we have it there. So here I can just call this. I think I could do. Let me do here optional. If this is empty, I'm going to return null. And if this is not empty, I'm going to do get. And then I'm going to return just this. So what about the delete? So the same. I'm going to do here find by name. And what do we have to modify? So we will have to modify the collection of fruits if we are deleting, right? So I'm going to do if there is a fruit, then I will try to delete it. And I'm going to pass here, I'm going to do like delete. We'll create the method in a second. I'm going to get the fruits from my root of provider. Fruits. So I'm going to create this method. I'm going to do protected, delete. This is going to take the list of fruits. And this is the fruit. So deleting an item from a collection, just remove. And we can use here store params. And I could do fruits. And that will be how easy it is to implement the persistence. So let me run the test. I have some tests. Hopefully most will pass. Some will still not pass, but that's expected. This one, I was not expecting this one to fail. Okay, so I have a test which is kind of business rule, which is like if you cannot save 2 fruits with the same name. So before adding a fruit, what we should do is if find by name fruit get name is present, we're going to throw an exception that we have, like kind of a fruit duplicated exception, because we don't want to have 2 bananas in our application. Let me run the test again. And all these tests will pass. The health and the micrometer we will implement shortly. So I'm going to run the app, and let me actually do something. So this is the data that Microstream has been creating in my test. for the dev environment, so I have here, I'm using one feature of Micronaut, which is default environments. I can have an application dev.yaml, and I can have like a different folder for development because I maybe don't want my dev data. So I'm gonna write this in users del Amo jcon dev, something like that. Hopefully this works. So I'm gonna try to run the app. Of course, something is running. I don't know what is running, but let's try. App started in 300 milliseconds. Is running import localhost 8080. If I do a curl request against fruits, there should be no fruit. So you see the empty array here. I can now save a fruit. So if I go here to do a post request against fruits, and I save a banana, so it tells me that a fruit was created and there is a banana. And if I retrieve it, is there. The fruit is in memory, so extremely fast. What you might be wondering is, does this actually work, or is just an illusion that is actually not saving? And it should work. So this is the folder that Microstream has been using to save in my computer under my user jcon dev. So if I stop the app, so stop. If I now do the curl request, no tricks here. If I do the curl request, nothing running. If I run my app with run, so you see here that this is running in the dev environment. If I do the curl request, I have the banana there. So really easy, as you saw, to create persistence with Microstream in combination with Micronaut. We have a couple of things to make things easy to test that it works. I have an example here that I'm going to show you. So when you write persistence, so that you don't forget the golden rule that you are actually saving what has been modified, Micronaut tests are so fast that it's really nice to write a test which actually starts the application, saves something, stops the application, and then starts the application again. So I have here a control, a test, which starts a server here. It says a bunch of fruits, and then it stops the server and starts again and checks that the fruits are still there. So you see I am starting a server here with a try with resources of Java. This will essentially close the embedded server, and I am starting the server again, getting a new HTTP client, doing the request, and checking that the things that I saved in the test are still there. So you can write really easy functional tests that actually verify that your persistent logic is working without even trying the application. But if that was not enough, Microstream uses a graphical user interface, which is especially useful when you are starting. And they allow you to see this kind of, the way I like to see is like when these GUIs that we have to visualize a relational database. It's kind of the same thing, but to visualize a persistence build with Microstream. So the way what they did is great. They essentially created like the GUI, and you can, if you create a REST interface which is compliant with the GUI, you can consume it. And what we did in the Microstream integration is we created that that REST layer, and we ship it as an additional dependency that you can add. So let me show that to you. Because you don't want to accidentally expose the REST interface, because you will be basically exposing all the contents of your persistence. we have made an effort to make you be secure. So I'm going to add a dependency. I'm going to add it only as development only, which will be picked only when I run my application in development mode. But not just that, we are going to have to enable it. So let me add the dependency first. So I'm going to come here and I'm going to do the Microstream dev. Rest, sorry. So this is the dependency. And this will basically expose an endpoint with the path Microstream, which is configurable. And it will expose a REST endpoint as the Microstream GUI is expected to be. So I added the dependency. I have now to do one extra step, which is go to my configuration and enable it. So I'm going to go here, I'm going to do, and this is documented as you can imagine. I think it's REST. Let me see. If I remember correctly, if not, we will check the docs. So I'm going to do Microstream. Let me refresh Gradle to see if it picks the. I'm going to show you a feature which is pretty cool in Micronaut, is that we generate configuration from actually real code. So the configuration that we have here is good. So if I search in configuration reference for REST, is REST enabled true. So the demo gods of the autocompletion didn't. So I added the dependency, I enable it, and now if I run it, we will see an ugly warning telling me like, Sergio, be careful, don't expose this thing in production. And here is the ugly warning. So it's telling me like the Microstream REST endpoint is enabled and you are not running a test environment. Watch out, right? So I have my application running in localhost 8080. I went to the Microstream documentation and so if you go to docs, so if you go to Microstream 1 and you create docs and you scroll here, you see the REST interface, client GUI. They tell you can download it's a jar file basically. So I download it to my computer. So I have here if I go to I have like a folder here in my user called applications. And I have here the client for Microstream 8.1. So I'm going to run it with Java -jar Microstream 08. And I'm going to do server port. By default, it will start in 8080, and the Micronaut application is already running in 8080, so I'm going to change to 8081. So I think it's running, but not 100% sure. So I'm going to go to localhost 8081, and this is the GUI. It tells me to connect. I'm going to pass so by default, our endpoint is Microstream. You can configure this, and it's running in 8080, so this should be able to connect. So it connects, so I'm in my root object. It has like a array list of fruits as we design it together. And inside we have one element, which is bananas. And if I come here and I do another CRUD request, and I save apple, if I think I have to refresh. We should be able to see the new element. So the GUI is really useful, especially when you are starting with Microstream and you have not internalized this rule of the things that you have to save is the thing that you modify because you get like a visual representation. But my recommendation is try to write tests in your application that actually save things, stop the application and start the application, because that way you will have the confidence of having this in a test suite and not just that you check it in the UI. So that's the GUI. I'm going to mention just fast, if you had in a Micronaut application two Microstream instances, because you may have to want two different graphs, you can inject with a qualifier the one that you want to inject. So you will use here like something like named inject, and you will the one we call it main. But if I have here like another one, if I had here like a second one, and I call like other graph, you could inject here another one with other graph, right? So we support multiple instances of Microstream. So that's good. I'm gonna show you, I have still 3 things to show you. We have integration with the health endpoint. Since many people here are new to Micronaut, endpoints in Micronaut are similar to Spring Boot actuators. So the health endpoint is the endpoint that you will use for a check. So I'm gonna come here, I'm gonna add one dependency, which is the management dependency, which is the one that will give you like the health endpoint exposed by default. By default, the Microstream will collaborate with the health endpoint. We are gonna have to add details so that we see visible the details, otherwise we will just see a status app. I'm gonna run my application, and if I do here curl localhost health, you see the health endpoint. This is like a bit verbose because we said like show the details to everyone, and you see here the Microstream participating in the health endpoint. So Microstream Micronaut is integrated with the health endpoint by default, and this is good because this will allow you, if you are like writing to disk in something like a mounted disk, and the mounted disk is for whatever reason not mounted, you will see like an error, and you will see that your application is not up or something like that. We also have integration with so Micronaut integrates with Micrometer, and we can expose a couple of metrics using Micrometer. So if I go here and I add the Micrometer dependency, if I have a test, so I'm going to actually copy the name of the metric. So there are 2 metrics that will be automatically added. So if we run up the application, I can go here and do curl localhost 8080 metrics and the metric name. Yeah, that's the response from the metric. And we have another one, which is the live data length. Live. So we integrate automatically with Micronaut Micrometer. There you go. So that's all I had for in terms of persistence. We have another integration with Micrometer, which is Micrometer has like a cache implementation, which is compatible with JSR 107, and you can use it in Micronaut out of the box. So Micronaut has a module called Micronaut Cache that you can use with. There's a question? Yeah, go ahead. You can specify a different thread pool, yeah. Yeah. So typically in Micronaut, when you do like a blocking operation, you will annotate your controller with at execute on. I think I have my controller annotated probably. So Micronaut support different runtimes. The default one is netty. And when you are like doing an operation downstream that is blocking, you should offload the main thread pool. And the at executes on annotation will do exactly that. So the question is, can you like do the writing operations in a different thread pool? And the answer is yes, you should do that. Yeah. Thank you. I'm going to show you an example of using Microstream with cache. So I have here, I don't know, this is the best example I could come up with. I have imagine you are like creating a backend for a newspaper, and often in a newspaper you are going to have to cache a lot the news because the news they don't change so often. So I have here like a news controller which basically gets like the news of a particular month, and it uses a service. And in my service, I have here like by design, I introduce like a 3 seconds delay when you book it the first time, right? And I am using annotations from Micronaut. The first one that I am using is called cacheable, and this basically will use the method parameters as the cache key. And then I have here like a cache put, which when I save like a deadline, it will cache it, and then I have like a way to invalidate the cache with cache invalidate. And last but not least, I have here at the top of my singleton, I have like the name of the cache. So how do you, and the test that I have a test. I am using these features from the unit, which is called test method order. So this test will be executed in order, and I am using timeout. So you see like I am giving like a timeout of 4 seconds. Remember like I added like a delay of 3 seconds. So I'm saying like the first annotation of November doesn't hit the cache, and the second one does. If cache was not working, since I have here like an aggressive timeout of 1 second, and I was repeat for 3 seconds, this test will fail, right? So I have like a set of tests that verify that actually there is a cache being used. So how can you use Microstream as cache? Pretty simple. You come here and you add the Microstream cache dependency, and then you add configuration for the cache, and you do here Microstream. The cache configuration, you give the same name here as we used in the cache config. So it's not a coincidence that headline here matches the name, and then you specify the key of the cache and the value of the cache. And if I now run my test, the test should pass. So the beauty of this is that Microstream cache is an implementation of the JSR 107. So it's kind of a drop-in replacement. So that's another great way of starting with Microstream, is trying to use it as your cache persistent layer. And once you get comfortable, I recommend you like to try to use it as a persistent engine. I think I have 4 minutes and I am almost done. So let me see what I have. I show you and recommend you like, please write tests that start your application, save something, stop the application, restart the application, and verify that the data are there. Show you how to use the Microstream annotation at store params, at store return, and at store root to simplify. I show you with annotations, but if for whatever reason you were to resort to, so we are not hiding things for you. We have like things to make your life a little bit easier, but if you want to use the storage manager directly, which you may have seen in other examples of using Microstream, you can resort to do that. So that's completely fine. You can inject a storage manager and work directly with that if you prefer. For me, it's a bit easier to say like, I pass you this method, save this parameter, and hide me of all these details. But behind the hoods, we are actually doing pretty similar code as this one. I show you that we integrate with Micrometer. I show you that we integrate with Health Endpoint. I show you that we have like a REST interface that you can use to connect to the Microstream GUI. And last thing I show you is that you can use Microstream as a cache. And I have a talk tomorrow where I will talk about how to go to production to AWS with Microstream and Micronaut. So if you want to see more and talk more about how to use, because at the end of the day, we all like to go to production, so that's tomorrow. And I will talk tomorrow about the different storage that we have. So today I show you here like file storage, so writing to file, writing to disk, which is great. But if you want to say, for example, to S3 or to PostgreSQL or to DynamoDB, we support those. And I don't know if I have time for questions. There is a question, yeah? Yeah. So in terms of how to scale the application, I will talk about that tomorrow. But typically, you will scale vertically. You will not scale horizontally. So the question is, this applies to only one instance. How does it work if you have multiple instances? I will talk exactly about that tomorrow. But the answer to the question is, when you are working with Microstream as persistent, you typically scale vertically. They have a solution which is the Microstream cluster, if you need to scale horizontally. But for most applications, especially when you are starting, scaling vertically should be the way to go. Are there any other questions? Yeah. So the sample application that I show you is what we have in the guide. The cache we don't have a guide yet, but we will have. But the fruit sample application is actually the same that is in the guide. In the guide, actually, I implemented persistence. So this is one thing about Microstream is you can create the root graph as you want. I think in the guide I implemented with a map. So today I implemented with a list, but in the guide it's implemented with a map. So if you go to guides.micronaut.io, just search for Microstream and you will find the sample application. The sample application is actually written in, I think we have it in Kotlin, we have it in Java, Groovy, and Maven or Gradle. So if you prefer Maven, you have the sample application there with Maven. Any other questions? Yeah. So the question is, do you have to load all of this into memory? The answer is yes. Microstream has capability to load things lazily. Maybe Florian can correct me, but I think by default they load only the object IDs eagerly, and then you load the rest of the things lazily. They also have like a type called lazy that you can add to your collections, so that if you are like worried about startup time, you can essentially like start with things not loaded by default, and when you need them, you are like loading them into memory. You can, if you have everything in memory, things will be relatively fast. If you have less memory than the size of your data, you will have to offload the data that you don't need. Yeah. So the question is, correct me if I misunderstood, is you have to design your application thinking about your access patterns and depending on the volume size. Yeah, that's always the case. So whether you use Microstream or you use a persistent, you use DynamoDB, you will have to think about your access patterns and design the database accordingly. I am, for example, using Microstream for a pet project where it's like a multi-tenancy application. And one of the things that I have is like a map with all my tenants IDs, and the things are lazily loaded for the tenants that are not required. So if a tenant accesses the application, I load this data, but for the other tenants, until they require the application, the data is lazily loaded. So, one second. Yeah. Do we support like the, streams of data? So we support several ways of streaming data in Micronaut, not really related to Microstream, but we support like JSON streams. So you could create those, but it's not related with the Microstream persistence. So at the end, is in Microstream is like you have a Java tree. So you can do anything that you can envision with that. Mm-hmm. Mm-hmm. Yeah. So how do you design your application for concurrency? More or less is the question. Um, so the way I am designing is I have like a tenant unit identifier to separate these collections of the information of tenants. For reads, there are no issues. So you have all the data in memory, and when they identify, you are like essentially selecting subparts of the graph. For writes, you will have to synchronize. You will have to synchronize when you write things. And Micronaut with the annotation will do that automatically. We even have you like an ability to customize the way you synchronize. But yeah, there is no issue. Any other questions? About the streams things, we support WebSockets as well in Micronaut. So if you want to have like a WebSocket connections and be pushing changes through a WebSocket, that's absolutely possible as well. And JSON events, sorry, server-side events. So if you, I don't think so. I will have to check, but I don't know. No more questions. Thanks a lot. Hope to see you tomorrow in the talk, and I am around in the conference if anyone wants to ask me anything about Micronaut or whatever. So happy to answer. Thank you.